Hi folks, today we're going to take a look at one of the most fundamental skills in high school algebra, and that's factoring polynomials. We won't look at all the different techniques that are possible, but we'll look at the ones that come up the most frequently, especially quadratic trinomials and difference of squares. The most important thing when you're factoring is to make sure that you can recognize the basic types. And the types we'll look at today will involve either 4 terms, 3 terms, or 2 terms. The first thing you always need to look for when you're factoring is a greatest common factor, which I've called GCF. So always look for that first. After you've done that, all you need to ask yourself is how many terms are there? If there are 4 terms, we'll look at the technique of grouping. If there are 3 terms, then we're likely looking at a quadratic trinomial, which break apart into 3 different kinds. Short, where you have an x squared at the front, and then blah blah blah. Long, where you might have a 3x squared at the front. And perfect square, which are a special subset of those. And if there are 2 terms, then you're looking at difference of squares. Factoring is basically unmultiplying some kind of expression. So whenever you've factored, you can always check by multiplying back out. So let's suppose that we had some question that asks us to factor x squared minus 7x plus 12, which we haven't talked about how to do at all yet. And we happen to get the answer, and I'll show you how to get this answer in a few minutes, x minus 4, x minus 3. And we're wondering, are we right? Did we do it properly? You can always find that out. All you need to do is expand, multiply out. Your x times your x would give you an x squared. Your x times negative 3 gives you negative 3x. Negative 4 times x, that's minus 4x. And negative 4 times negative 3 is plus 12. Some people call this foiling the binomials. And what we'd end up with is x squared minus 7x plus 12. Since we found some set of binomials that multiplies to x squared minus 7x plus 12, which is what we started with, we must have factored it properly. So yay, we did it right. So you never need to be guessing whether you've done your factoring properly. You can always check by multiplication. All right, let's take a look at some of the different techniques. So the first one that you always look for is a greatest common factor. It's an expression by which all the terms are divisible. And again, look for it first before attempting any other factoring methods. So let's suppose we had this expression here, 12q cubed plus 9q minus 15. What are all of those terms divisible by? 12, 9, and 15 can all be divided by 3. That means that 3 is their common factor. They can't all be divided by q because 15 over here doesn't have a q, so you can't divide a q out of it. When we factor it, we put that 3 out front, and then we ask ourselves what would be left over. So if I took my 12q and divided it by 3, I'd be left with my 4q cubed. 9q and divide it by 3, that'll give me 3q. So I'll write that over here. And finally, negative 15 divided by 3, that'll give me negative 5. Is it right? Let's find out. So this is the answer, the factored answer right here. This is the checking step, which is optional, but helpful. Is it right? Let's find out. 3 times 4q cubed, 12q cubed. 3 times 3q, 9q. 3 times negative 5, negative 15. Is that the same as what we started with? Absolutely it is. Yes, we did it right. Okay? But again, that expression in blue is the one that's your factored form. Okay, let's try another common factor. Factor 21x cubed y minus 35x squared y squared plus 7x squared y. So you can probably figure out the number by which they're all divisible. 21, 35, and 7. You can divide all of those numbers by 7. The x's, they've all got at least a power of x squared. So the smallest power of x that you see on any single term is an x squared. That means it could be divided out, or it could be a common factor. As far as the y's go, the smallest power that's on every term would be a y to the 1. So that can also be divided out. We end up with a common factor of 7x squared y. So we put that out front. And we ask ourselves, what am I left with? 21 x cubed y divided by 7x squared y. 21 divided by 7 is 3. I had an x cubed. Now I've taken out x squared. That just leaves me with an x. And the y's, I've taken out the y. So that one's gone. Okay, the negative 35x squared y squared. I took out a factor of 7. That means I divided it by 7. So I'm left with negative 5. Negative 35 divided by 7 is negative 5. I took out the whole x squared, so there's nothing left there. And I took out one of the y's, so I'm left with one of the y's. This is the one that people sometimes mess up. 7x squared y. If I take out a factor of 7x squared y, I'm not subtracting that off. I'm dividing it. So 7 divided by 7 would give you 1. And the x squared is taken out, as is the y. Again, if you're not sure, all you have to do is check with multiplication. Let's check. Does it give us our original expression? That would give us 21 x cubed y. Yep, that's good. Minus 35 x squared y squared. That's looking pretty good. And finally, we get 7x squared y. Is it the same as up here? Yes, indeed. We've done it properly. So this was our factored result. The red is just the check. Okay, always looking for greatest common factors first. If we just take a quick gander back at the first slide, now we're going to look at the different types of factoring that occur depending on the number of terms you have. So we'll take a look at what happens if you have 4 terms. When we have 4 terms, we're going to attempt something called factor by grouping. And grouping just means putting terms in pairs. So when you see 4 terms, you're going to group them in pairs of brackets with a plus sign between those pairs of brackets. So here we go. I'm going to make my brackets. I'm going to put my first 2 terms over here. My next 2 terms, I'm going to keep that negative with the 8x. Next 2 terms go in the last set of brackets. Nothing has changed here in terms of the meaning. I've just put a couple of extra brackets in there. What that allows me to do is take out a GCF, or greatest common factor, from each bracket. And what we want to do here is create identical brackets. So in this first bracket up here, 6x squared plus 9xy, I can take out a greatest common factor of 3x. That leaves me with 2x plus 3y. In the next bracket, I've really got 2 choices as a common factor. I could take out 4, or I could take out negative 4. What's going to be nice about taking out negative 4 is that if I divide out a negative 4 from negative 8, that leaves me with a positive 2x and a negative 4 coming out of a negative 12. So I divide them out. That gives me a positive 3y. Now I have these identical brackets. Okay? And they're really common factors of 3x and the negative 4. So they're going to be factorable easily. If we didn't have identical brackets, then this method really wouldn't work. We'd need to make those identical brackets, and if that's not possible, then it's not factorable. Okay, our last step, once we've got that, is to make 2 binomials that are multiplied together. So no plus between them anymore. One bracket is those identical brackets we made. That was 2x plus 3y. The other is the coefficients from those brackets, the 3x and the negative 4. As per usual, we can ask ourselves, well, did we do it right? let's check. There's no reason for us to wonder. So if we checked, we'd have 2x times 3x is 6x squared. 2x times negative 4, that's negative 8x. This would give us 9xy and negative 12y. Is that the same thing as we started out with? Absolutely it is. It's in a little different order, but that's no problem for us. Okay, so we've dealt with what to do when you have 4 terms. The next thing we're going to look at is trinomials, or expressions with 3 terms. And there's special kinds of trinomials called quadratic trinomials. That means that the highest power that they have on x is a squared. There has to be an x squared in there and no higher power than that. They fall into 3 categories. And these are the names that I give to them anyways. I call these ones short trinomials. And the reason I call them short trinomials is that they don't take very long to do. Short trinomial has a coefficient of 1 in front of its x squared. So we never actually see that. It starts with an x squared, or an a squared, or a y squared. The technique for factoring this, and it is a quadratic trinomial because it has an x squared in it, the technique is to look for numbers that multiply to the last term, which would be negative 18. So we need numbers that do this. Multiply to negative 18 and add to the middle coefficient, which would be 7. It really doesn't take you long to go through all the ways to multiply to 18. And you know that since they multiply to negative 18, one of the 2 numbers you're looking for has to be negative. So I could try the numbers 1 and 18. Those multiply to 18. And I could do it this way. If I do it like that, those 2 numbers add to 17. That's no good. We need them to add to 7. If I do it this way, then they add to negative 17. That's no good. We want them to add to 7. All right, next way to try to multiply to 18. 1 and 18, 2 and 9. Let's see what works here. Let's make one of those negative. So negative 2 and 9 really multiply to negative 18. Do they add to 7? Absolutely. And since you won't be talking this through in your head, you'll be able to do it way faster than that. Okay, so we found our 2 numbers. Yay! They are negative 2 and 9. And here's all you have to do. Write x minus 2 in one bracket and x plus 9. We can check, of course. X times x is x squared. X times 9 is 9x. Negative 2 times x is negative 2x. And minus 18. We did a great job. We ended up with x squared plus 7x minus 18. We must have factored it properly. Okay, so the method here is look for numbers that multiply to the last term and add to the middle coefficient. The next trinomial type we'll look at are what I call long trinomials. They're not hard, they're not complicated, they just take a little bit longer. And that's mostly because there are more possibilities to check by and large. A long trinomial takes the form ax squared plus bx plus c, where a is not 1. All that means is it starts with a number in front of its x squared. So it might be 5x squared plus 2x minus 7. Something like that would be a long trinomial because of this number. There are a few methods that you can use. The preferred method, as far as I'm concerned, is inspection, which is really just looking at it or guessing and testing. Since we know that factoring is always verified by multiplication, or that we can check it, we know that if we find 2 binomials that multiply to give us the original, then we've factored it. Now, you don't have to test every possible number in existence. There are only a certain number of possibilities. So here's how we're going to set up our guess and test. We'll have 2 sets of brackets to be multiplied together. The terms at the front of each bracket should multiply to your first term from the trinomial. Okay, so for us that would be 3x squared. The terms at the end of each bracket, when we're multiplying, should multiply to give us the last term of our trinomial. So the last term of our trinomial would be -4. So I did that just below. I set up two brackets, and what I'm saying is that the numbers that go in here multiply to 3x. The numbers that go at the end of each bracket multiply to -4. Okay, if I want to multiply to 3x, there really aren't that many possibilities. I'm going to need a 3x and an x. If I want to multiply to -4, there actually are a fair number of possibilities. So let's try some. This may take us a couple of minutes because we'll try a whole bunch of them. But you end up getting a fair bit of insight pretty quickly on which ones are likely to work. Okay, so let's try. It could be a 1 and a -4. I could have, this might be the binomial. The first and lasts are guaranteed to work. All I need to figure out here is if I have 3x plus 1 by x minus 4, what does that give me? I know I'll get 3x squared as the first. I know I'll get -4 as the last. But in terms of my x's, I'll get a -12x and a +1x. Is that the same as the middle term that I want to get? Absolutely not. That's -11x, and I wanted +4x. So this isn't the right way. I'll just try a different set of possibilities then. So instead of +1 and -4, maybe I'll try -1 and +4. Okay, try this one out. I'll get +12x and -1x. That's 11x. That's no good to us either. Okay, maybe I need to put the 4 over on this side. Have a +4 and a -1. Let's see what that does in terms of my middle terms. I'll get a -3x and a +4x. That's 1x, and what I wanted was 4x. No, that's no good. Okay, maybe I could switch something else around. Do it this way. And that's going to give me +3x and -4x. That's -x. That's no good either. I wanted a 4x. So I've been through a whole bunch of possibilities here, but there are a few more. My last terms need to multiply to -4. So why don't I try, I don't know, a +2 and a -2. Okay, this is going to give me -6x and +2x. That's -4x. Oh, I feel like we're close here. Let's try a different set of possibilities. This is going to give me, when I multiply it out, and I'll test the whole thing, 3x squared plus 6x minus 2x minus 4. We must have done it properly because we're getting 3x squared plus 4x minus 4. So that goes pretty quickly once you get the hang of it. If you found that that really didn't sit well with you, you don't like this idea of guessing and testing, or your multiplication isn't that strong, there's an alternate approach that we'll show at the end of this video, and I'll use the exact same example. Okay, I tried absolutely every wrong possibility before getting to the right one in this case. So, if I had gotten a little more luck, it would have gone faster. Alright, perfect square trinomials. If there's any of the types in this presentation that you could probably get away without, it would be perfect square trinomials, because if you can do your short and your long, these are just a subset of those. But it can save you some time by recognizing perfect square trinomials, and they have some applications when you look at doing some graphing later on. Alright, so for perfect square trinomials, they're ones that factor this way, like a plus b squared, the same binomial, just squared. They have the following properties. Its first term needs to be a perfect square. The last term in the trinomial needs to be a perfect square. And the middle coefficient needs to be either positive or negative. That's what this little symbol here means. 2 times the square root of the first times the square root of the last. So I gave us a trinomial here, 25x squared minus 40xy plus 16y squared. Let's test these conditions. Is the first term, the 25x squared, a perfect square? You betcha. It's 5x all squared. If you squared 5x, you get 25x squared. The last term, the 16y squared, is that a perfect square? Absolutely. It's 4y all squared. And is the middle either positive or negative? 2 times the square root of the first times the square root of the last. Now, I like to do these just with the coefficients because it saves time. But if you like, you can do it with the x's and y's as well. So let's check it out. Let's see what we'd get if we had 2 times the square root of the first, so square root of 25, times the square root of the last, which would be square root of 16. We would get 2 times 5 times 4, which is 10 times 4, or 40. Is the middle term, right over here, is that really positive or negative 40? Absolutely. So they have the same value. It's okay that it's negative. That doesn't make a difference to our test for a perfect square trinomial. Okay, you might say, well, that's not saving us a lot of time so far. But at this point, it will. Once it passes all 3 conditions, you get to factor it really, really fast. It's going to be one binomial all squared. The first term in it is going to be 5x, which was just the square root of your first. Okay, the square root of this one. The last term will be 4y. And that was the square root of your last term. The symbol that goes in between them, either plus or minus, comes from this symbol right here. So since this one in the middle of the trinomial is negative, we get a negative here. That's how it factors, 5x minus 4y all squared. As always, we can check this. Let's see if it works. 5x minus 4y all squared. That means 5x minus 4y times 5x minus 4y, which would be 25x squared minus 20xy minus another 20xy plus 16y squared. Oh, it works out. We get the same expression we started with. Okay, so test those 3 conditions, and then you just have square root of the first, square root of the last, it's all squared, and sine of the middle. The last different type we're going to look at is when you have 2 terms. So if you have 2 terms, the only possibility that we're looking into, though some others do exist, the only one we're considering is difference of squares. And it's named really well. It means difference, which is minus, of 2 squared terms. So there are 2 perfect squares with a minus sign between them. Let's see, does 16x squared satisfy that? 16x squared minus 9, rather. So we have to check, is this a perfect square? Yes, it's 4x all squared. Is this one a perfect square? The number 9? Yeah, it's 3 squared. So far, we have 2 perfect squares. Is there a minus sign between them? Yes. Test those 3 conditions. And these ones factor like this. You'll end up with 2 brackets. One's going to have a plus, one's going to have a minus in it. At the start of each bracket, you get the square root of the first term. So the square root of 16x squared would be 4x. At the end of each of these brackets, you'll end up with the square root of the 9, or the last term. Okay? So square root first, and finally, square root of the last. Check them. Let's see what we get. We'd get 16x squared minus 12x plus 12x. Ooh, that's going to be 0, which in turn gives us 16x squared minus 9. These kind of terms like this, or these kind of pairs of binomials, where you have the same terms, but one has a plus, one has a minus in it, these are called binomial conjugates. All right, if you're okay with the idea of guess and test or inspection for the long trinomials, I suggest you stop watching at this point. If you want an alternate approach for factoring long trinomials, here we go. So long trinomials, an alternate approach. Long trinomial still takes the same definition. If it has something in front of its x squared, then it's a long trinomial. Although inspection is the preferred method, there's an alternate approach called decomposition, which splits the middle term into two parts. Once we do that, once we split the middle into two parts, we'll have 4 terms, and we can factor by grouping 2 and 2. Sometimes it's a little faster, often not, though. Its real only selling feature is knowing whether things are easily factorable or not. When you're guess and testing, you really don't know if there's an easy factorization or not. So, if we have this long trinomial, we're looking for numbers that add to our middle coefficient. So middle coefficient would be 4. This looks kind of familiar, like a short trinomial. And multiply to the product of your first and last. So for us, the product of the first and last would be 3 times negative 4. That's negative 12. Okay, so looking for numbers that multiply to negative 12, add to 4. They're not that hard to find. We go through our possibilities. Turns out that 6 and negative 2 work. And what people are tempted to do then is go x plus 6, x minus 2. But if you check that with FOIL or with multiplying out, it's not going to work out for you. You won't get the original expression. For a long trinomial, there are a few extra steps, hence the name long trinomial. So I'm going to use the numbers 6 and negative 2 to split up or decompose my middle term. I'm going to take the term 4x, and I'm going to split it up into a 6x and a negative 2x. That still means the same as 4x. I've still also got my 3x squared and my negative 4. Okay, so I've just rewritten that trinomial as 4 terms. And if you'll recall, once you have 4 terms, then we factor by grouping. Sorry, this should have been a 3x squared. So we'll factor by grouping. We get 3x squared plus 6x. That goes in one bracket. Addition between the two brackets to start with. And negative 2x minus 4 goes in the other bracket. Take out a greatest common factor. That'll be 3x in this one, and it'll leave us with x plus 2. It'll be negative 2 in the other bracket, leaves us with x plus 2. And we factor by saying the identical brackets become one of our factors, and the other one, the coefficients, the 3x and the minus 2, become the other bracket. We already checked this factorization when we did the guess and test method. So you really have your choice, but if you decide to go with decomposition, you do have to get pretty quick with it. You want to be able to do a long trinomial in under 2 minutes, no matter what. Hope this has been helpful. There are notes that you can download of the presentation in the link below, so feel free to do that.